All right, folks, this is going to be a quick introduction to density, focusing on the most important information around density that you need to know for density in physical science. First, when we talk about substances of different density, we can take a look at what their particles might look like in terms of substances of varying density. And when I mean particles, I mean the little tiny atoms and molecules that make up substances that we cannot see with the naked eye. If we were to zoom in really close on substances that aren't very dense, we would see that their particles would be very far away. They take up large amounts of volume. Substances with medium density would have their particles a little bit closer together, sort of like this. And substances that are very dense have their particles very close together. They are usually solids, and you would see their particles arranged in a very ordered fashion. So these particles, for least dense, are very far apart. Medium density, the particles are closer together. And for most density, the things that are the most dense, the particles are really packed in tight, and those are usually solids. Well, we can also define density mathematically using mass and volume, because all of these particles, they represent matter within a substance, and that matter is represented by mass, and the amount of space that is taken up is represented by volume. So the more mass we have, the more dense it is. The greater the volume, the less dense it is. And we have a formula for this, and that's density equals mass divided by volume. This is similar to some of the other formulas we have seen during the year, and we can rearrange this formula to be mass equals density times volume, and we also have volume equals mass divided by density. The units for density are mass on top is grams, and volume on bottom is going to be cubic centimeters. Now, the official SI unit for mass is actually kilograms. However, most often in this unit, we're going to use grams for mass, although that is not the official SI unit for mass. We're just going to use grams because it's going to make the most sense for the situations we're going to see. So these are the units. And I'm going to just erase this equal sign just to make it clear that we're just talking about the units for these formulas. The units for mass are going to be grams, and the units for volume are going to be cubic centimeters. Now, there's two important things I want to point out. One is that we can do a triangle of density, mass, and volume to help us remember the formulas that we need. These three formulas can be found in this triangle, where density equals mass divided by volume, volume equals mass divided by density, and mass equals density times volume. Remember, this is multiplication and this is division. And here, one other important point. When we have cubic centimeter, what is cubic centimeter? Well, cubic centimeter is a cube where each side has the length of 1 centimeter. So each side is 1 centimeter. And, if we were to do this, we would see that this side is also 1 centimeter. So its volume is length times width times height. That's how we calculate the volume of a cube. Well, in this case, it's just 1 times 1 times 1, which is just 1. And when I do centimeters times centimeters times centimeters, this is centimeters cubed. That's why the volume of this cube is 1 cubic centimeter. And it just so happens that 1 cubic centimeter is also equal to 1 milliliter. The amount of space taken up by this cube is 1 milliliter. If we were to fill this cube with water, that would be 1 milliliter of volume. So cubic centimeter is equal to milliliters. And we're going to see that they're interchangeable throughout this unit. And what that means is for density, we also have grams per milliliter as a unit of density. You should go ahead and write these formulas and these units down in your pink sheet now. If you don't have your pink sheet, I'm going to be giving you a periodic table in class coming up. You can write them down on your periodic table when you get your periodic table. But these are the units that you will need. You should pause the video now in order to write these formulas and these units down somewhere so you have them. Before we go into examples of how to use these formulas, I just want to point out some important things about density. Namely, that density is an intensive property. What this means is that density is characteristic of a particular substance. For example, aluminum has a density of 2.70 grams per cubic centimeter. Copper has a density of 8.94 grams per cubic centimeter. However, so what this means is because they're two different substances, that's why they have two different densities. In this way, we can use density to figure out what a substance is. And if you change a substance, say through a chemical reaction or otherwise known as a chemical change, it will probably change its density. Density is a property of a specific kind of material. And if you change that material, it will change its density. That's what we see here in this density column on the left-hand side. Each substance in this density column is a different substance, so they all have different densities. And we see that items with the least amount of density float on top. And items with the most density sink to the bottom. This explains everything from why hot air balloons are able to float in the sky because their hot air is less dense. It also explains why boats float on top of water because they are less dense. And it also explains why we see oil and other substances float on top of water, because these oils are less dense. Less dense substances will float on top, and each different material has its own specific density. Let's now go through and do a couple of examples to see how we calculate density. This says a metal block has a mass of 562 grams and a volume of 54 milliliters. What is the density? Well, it's looking for density, so I use my equation for density. Density equals mass divided by volume. When I plug in my mass of 562 grams and my volume of 54, I see that I have to divide these. If I put this into the calculator as 562 divided by 54, I'm going to get 10.407, and I want to round to 2 decimal places. So I'm going to round up to 41, and my unit will be grams per milliliter, because these units do not cancel out. I divided mass divided by volume. I divided the mass by the volume to give me a density of 10.41 grams per milliliter for this metal block. That pretty much makes sense because it's a heavy density. The density of water, just so you know, is defined as 1 gram per milliliter. Okay, let's continue on. It says an object has a volume of 96 cubic centimeters and a density of 78.2 grams per cubic centimeter. What is the mass? Notice that this time it's using cubic centimeter for volume instead of milliliters. It's looking for mass, so I just need to use my equation. Mass equals density divided by times volume. I almost mixed it up there. That's my equation to get mass. In this case, it's 78.2 grams per cubic centimeter times 96 cubic centimeters. My density times volume. Notice here that centimeters cubes will cancel out because I have centimeters cubes on top and on the bottom. If I do 78.2 times 96, that's going to give me 7,507.2, I don't need to round, grams. That is the mass of my object. And I got that using density times volume. One last example of a density calculation. It says a large bottle has a mass of 1,423 grams and a density of 2.9 grams per milliliter. What is its volume? So we know the mass of this bottle. We know how dense it is, but we don't know how much volume it takes up. Well, lucky for us, we know the equation for volume is going to be density divided by mass. And I just plug it in now. I have 2.9 grams per milliliter divided by, actually, I think I did this wrong. The equation for volume is actually going to be mass divided by, actually, let me see here. Yeah, mass divided by density. I don't think that's what I had before. So I have mass divided by density, and That's my equation for volume. And now I plug in for mass 1423 grams, and I divide that by 2.9 grams per milliliter, which is my density. Notice here that grams is going to cancel out. And when milliliters is on the bottom of the bottom, it's in this unit on the bottom, but then it's on the bottom again. When it's on the bottom of the bottom, it's going to go on top. That's something we saw last semester. Because when I divide by 1 over milliliters, it's the same thing as multiplying by milliliters. Milliliters goes on top. And what I see when I plug this into the calculator, 1423 divided by 2.9, that gives me 490.689 and some other numbers. But when I round up, it will end up being 0.69 milliliters. So the amount of space that this bottle takes up is 490.69 milliliters. Today, what we did was we learned about how density is determined by how closely packed a substance's particles are. And the substance's particles represent its mass, and the amount of space they take up are represented by its volume. And we can put that into a formula for density, where density equals mass divided by volume. And if we play around with this equation, it gives us these three equations. These are the units for these three equations. And we went through examples. Well, we talked about how 1 cubic centimeter is equal to 1 milliliter. We talked about how each substance has its own density, and least dense substances will float on top. Most dense substances will sink to the bottom. And we went through examples of calculations where we had to find density, mass, and volume. We plugged in what we needed and had the right unit as an outcome.